How you doing, everyone? Sean O'Kane here with Chip Estimate TV. And welcome to the 55th Design Automation Conference in San Francisco. Let me tell you a little bit about Chip Estimate. ChipEstimate.com is an IP portal or ecosystem comprised of over 200 of the world's largest IP suppliers and foundries. And we're all working together very early in the design process to give designers like yourself the most up-to-date silicon-proven IP available on the market today. So what we do is we kind of bring the conversation with the provider and the designer together really early, and that's important. With me today is Mr. Marc Greenberg, Product Marketing Group Director at Cadence Design Systems. Cadence also has their complete IP catalog listed on ChipEstimate.com. Now our topic today, thank you for joining us.
Thank you. Thanks for having me.
Yeah, our topic today is memory requirements for deep neural networks in artificial intelligence and machine learning. Say that 5 times, ladies and gentlemen. So, just to give the broad overview, the capabilities generally classified as artificial intelligence include successfully understanding human speech, autonomous cars, interpreting complex data, including images and videos. Let's just start there. So cognitive technology is key to drawing rational business conclusions from the right data, so you can implement solutions with confidence. That said, what is the choice of memory? Why is the choice of memory important for AI and machine learning?
So it's really important for a number of reasons. It's either the primary determinant or the secondary determinant of the performance of the neural network, especially under the training condition.
Right.
So basically, if you think about a neural network, we've got a whole bunch of nodes throughout the network, a number of different layers, and each one of those nodes has got a whole bunch of data associated with it. It has weights, it has activations, and then there's data flowing back and forth through the neural network. So all of that happens in most systems connected to an external memory. I mean, people would love to put this on the memory on their chips if they can.
Yeah.
But most of the time, the size of data means that the data has to go outside to DRAM. And then when you're going outside to DRAM, now you create a bottleneck, right? The bottleneck is going to be a performance bottleneck unless you can solve the bandwidth problem on that interface. So that's why it's really, really important to choose a really good memory solution, a high bandwidth, low latency memory solution. That's going to be the biggest determinant of the training time, especially for a neural network.
So you may have already answered it, but you can expand on it. Why is memory so intensive?
So the intensiveness is, like I said, it's just every node in the design has got data associated with it. So storing the weights as it goes through as the training set goes through the neural network the first time, and then revising all that data as the data flows backwards through the network. Is basically all of those are just really data intensive operations. There's a ton of data that goes all over the memory. It's all all the regions, or all the regions of the memory are going to be used as you go through the neural network and back, and it just takes a lot of transactions back and forth to the external memory. It takes a lot of energy and takes a lot of bandwidth to do that correctly.
So what types of memory are people using for the deep neural networks?
So today, a lot of the neural networks are being run on graphics cards. So that's a sort of interesting dynamic. It turns out that the GPU is actually quite good at implementing a lot of the neural network functions. So a lot of people are using graphics cards today. So somebody who's using graphics card today is probably already using GDDR memory or HBM memory. Not because they particularly chose that memory, it's because that was what was available on the graphics card. Now, what we're seeing a lot of our customers now are moving towards is building custom ASICs, and so now the dynamics might change a little bit in terms of what memory they may choose to use for a custom ASIC or a custom SoC that's going to implement a neural network function.
Let's talk about drawbacks, possible drawbacks. What are the drawbacks using DDR4 and LPDDR4 for AI and machine learning applications?
So those memories are the off-the-shelf memories today. DDR4 is going to be in your PC. Most of your servers are going to be DDR4. LPDDR4 is going to be in your mobile phone. Those weren't really designed for the neural network application.
Okay.
So they have a particular amount of bandwidth that they can provide for the amount of capacity that they provide. They tend to be more capacity oriented, providing a lot of capacity with relatively modest bandwidth. The needs of most of the AI systems, especially in the training mode, is going to be to require a lot of bandwidth and relatively little capacity. So we need to do something that's sort of the opposite of DDR4, LPDDR4. So our existing customers in the AI space today, they're predominantly using DDR4, LPDDR4 because that's kind of what's been available. But towards the future, we're going to be looking at something different.
Talking about the future, I mentioned before, we're entering in a new kind of a historic era in artificial intelligence driven by advances in deep learning, and HBM, which we'll touch on, is critical to making all this happen. So why are GDDR6 and HBM2 better suited for these training applications?
So both the HBM2 and the GDDR6 offer that ratio in a correct kind of way. So they're offering a lot of bandwidth and relatively little capacity. And basically what that means is that you get the bandwidth that you need for the application that you want, but you don't have to buy so many memory dies that would become cost prohibitive to get that bandwidth.
Right. And why aren't people using the GDDR6 for all their artificial intelligence for SoCs?
So GDDR6 is something that's just sort of coming out now as a thought. So again, if you're using a graphics card, you've probably already got GDDR6 on there. But if you're building a custom processor, a custom AI processor, a custom neural network chip, you haven't really had access to the graphics memories before. And the difficulty has been, proving out a type of memory that was designed for graphics in a new application area.
Okay.
So what people have been doing, the graphics memories like GDDR5, there were a few chips that were produced that supported GDDR5 that were not GPUs. There was one from one of the larger CPU manufacturers, one of their sort of custom AI processor lines supported GDDR5, and then there were some networking products out there that supported GDDR5 as well, but it didn't have really broad adoption. What's happening now is as this AI market continues to grow and grow, GDDR6 is starting to look like a good technology for that. And again, it's finding this match of the right amount of bandwidth with the right amount of memory capacity. It seems that GDDR6 is just kind of fitting right into that gap right now. So we're seeing demand for that out of our customers looking to produce AI chips.
So for all your compute intensive tasks for AI and deep learning, just go to Cadence.com and also talk to Marc Greenberg.
Sure.
So I really appreciate you spending a little bit of time with us here at DAC. So for Marc Greenberg, my name is Sean O'Kane. We'll see you next time here at DAC. Thanks.
Thank you.
All right.